connection establishment phase. Second one is data transmission phase and connection termination phase. Okay. So coming to the connection establishment phase, the step one is the client side. Okay, TCP first sends a special TCP segment to the server side TCP. So this special segment contains no application layer data, but one flag bit in the segment's header, that is called SYN bit. Okay, which is set to 1. For this reason, this special segment is referred as SYN segment. So in addition to that, the client randomly chooses a initial sequence number. So here we have given sequential is equal to X, that is client ISN, and put this number in the sequence number field of the initial TCP SYN segment. Okay. In the step 2, once the IP datagram containing a TCP SYN segment arrives at the server host, the server is going to extract the TCP SYN segment from the datagram, allocate the TCP buffers and variables to the connection, and sends a connection granted segment to the client TCP. So this connection granted segment also contains no application layer data. However, it contains three important pieces of information in the segment header. The first is SYN bit is set to 1. Second is the acknowledgement field of the TCP segment header is set to client ISN plus 1. See here client side we have given sequence number of X here according to this example. So the acknowledgement number will be X plus 1. Finally, the server chooses its own initial sequence number, that is the server ISN, and puts this value in the sequence number field of the TCP segment header. So this we are going to call it as SYN acknowledgement. So SYN acknowledgement we are going to send. So that's why acknowledgement bit is equal to 1. Okay, this is actually the step 2. In step 2, there are three important information. It won't contain any application layer data. So the first important parameter is SYN bit is set to be 1, and the second is acknowledgement. So the acknowledgement will be the client ISN plus 1. So in this case, the client number we are given is X. So the acknowledgement number will be X plus 1. So the sequence number, it is going to take it as Y, and the acknowledgement bit also it is going to send because it is sending the acknowledgement along with the TCP segment header. So next step 3, this is a step 3. So upon receiving this SYN acknowledgement segment, the client is also going to allocate the buffer and variable to the connections. So the client host then sends the server at another segment. So this is the last acknowledgement, the server connection granted segment. Then the SYN bit will be 0. So since the connection is already established, this third stage of three-way handshake may carry the client to server data in the segment payload. Okay, so this is about connection establishment in case of TCP. So we can have connection termination also with respect to, instead of SYN bit, we are going to use the FIN bit. Okay, FIN bit is equal to 1 with the sequence number. That is a step 1. And step 2, it is going to give the acknowledgement with the client ISN plus 1, that is X plus 1, with the acknowledgement bit 1. Again, the server is going to set the FIN bit is equal to 1 with the other sequence number, and it will receive the acknowledgement. So this is the last acknowledgement, and after that the connection will be terminated. So we can explain the same concept with the help of state transition diagram. So in case of connection termination phase, either of the two processes participating in a TCP connection has to end the connections. So when the connection ends, the resources like buffers and variables in the host that all to be delocated. So for the connection termination, TCP sends a segment with the FIN flag set to 1. So when the server receives this segment, it sends the client an acknowledgement segment in return. So the server then sends its own shutdown segment, which has a FIN bit is equal to 1. So finally, the client acknowledges the server shutdown segment. At this point, all the resources in the two hosts are now deallocated. Now, this is actually the state transition diagram of things. See, first, it will be in the closed state. The SYN will be sent. The client application initiate the TCP connection. It will send the SYN segment. After that SYN sent, it will receive the SYN acknowledgement and send the acknowledgement. Then the connection is established. After establishing connection, data transfer takes place. To terminate the connection, we are going to send the FIN. The application initiate the close connections. FIN will be in the waiting state 1. Again, it will receive the acknowledgement. Wait state 2. Again, it will receive the FIN. Then time wait for 30 seconds. Again, it will terminate the connections in the client side. In the server side, what will happen is first it will be in the closed state. Server will application will create a listen socket and it will be in the listen mode. Whenever it receives a SYN from the client side, it will send SYN an acknowledgement. Whenever it is receives the SYN, it will acknowledge with the thing and connection will be established. And after that, it will wait for the connection closure. It will wait for the FIN signal and send the acknowledgement. It will be in the close wait set. Again, it will send the FIN. Again, last acknowledgement will be received. And after that, it will receive the acknowledgement and closes the connections. So this is a way, it is a state diagram of client and server architecture with the connection management. So next we will go to the network layer.